Okay, can you give a warm round of applause to Panos Louridas? Professor Panos Louridas from the Athens University of Economics and Business.
Right, so thank you everybody for sticking to the end. So I'm sure there are other things to do on Saturday evening, so I'm really grateful that you are here. I am at the Athens University of Economics and Business. I'm a professor there, but actually here I'm going to speak more as a programmer. So I'm a practitioner. I still try to program every day. It's not very easy when you become an academic. When you're a professor, usually you spend your time doing other things. I even know of people who were computer scientists who wanted to become professors so that they would stop programming, okay? Because you become a professor, you do other things. But I enjoy programming. And what I'm going to talk about is a few things that we can do with Python, especially Python and visualization tools. I say mostly Python because it's going to be Python plus something else. So it's going to be Python and some JavaScript. And we can use it for fun, and we can use it also for research, so you can see for a few examples. And as it happens, I realized after I made the presentation, all of the examples have to do with time somehow, right? So, or most of the examples. So that's the title of the presentation, time present, time past, because all of them relate to time. So the first one is, it has to do with a conference. There are these big research conferences that happen around the world. One of them is the ESSEC FSC conference, which is one of the top conferences in software engineering, which is my field. And in order to organize them, you have to submit a bid. So a few months back, last summer, we had to submit a bid to host the 2021 conference. Okay, so it takes a long time, and you have to prepare a folder and to submit to the organizers and convince them that you can host it and you can do a good job. So we started preparing the bid, and we realized that we needed help from the experts. So there exist companies that specialize in organizing conferences. So we contacted one of them, and they said, don't worry about that, we'll prepare your bid. So you don't need to do anything. So after a while, they came back with their proposal for the bid, which is a PDF document like this. So it has a nice picture of Athens, as you see. Then it goes on. This has another nice picture, which is not of Athens, so I don't know what's doing there, but anyway, this is a nice. And then it has these soldiers of the Presidential Guard. I don't know, perhaps they think it's nice. At least they got this right. This is our university, so they found a photo of the university. More talk. Then they found a very flattering photo of myself, because it's like 10 years ago or more, so I don't know where they found it. And then it goes on, and they say how good it is to come in Athens, and the hotels and the facilities and everything, and go on and go on. And then I see this, which I didn't say that I am a perfectionist, so this is a disaster. They wanted to show to the organizers how easy it is to get to Athens from other places of the world, so to show the flight connections. So they prepared this diagram, which it shows connections. Well, it's supposed to be showing connections, but actually it shows pretty much everything. So you see all these cities that there are no flights to Athens. So you can see Rostov, for example, or other places that there are no flights there. Or you can even see flights that do not go to Athens. So you see this red line that goes from nowhere to nowhere. Okay, perhaps I don't know, the NASA space station or whatever. I have no idea. So I see that, I say, wait a minute, this is awful. I mean, we are computer scientists, we cannot give that. And then I scroll down again, and I see this, which is another diagram showing how easy to get to Greece without a visa. Okay, because if you are not in Europe, from Europe, then you need a visa. And so they try to say that, don't worry, I mean, Greece is visa-friendly. So they have a table with certain countries that you don't need visa travel. And then they have another map here, which is also a disaster, because it just shows the European countries, which we already know that you don't need a visa. And the color coding is wrong. For example, they have already put the UK outside Europe or whatever. I mean, and also they took Ireland with them somehow, which, anyway. So that was the problem. Okay, so I saw that, I said, well, let's stop. I mean, this is not possible. So what do I do? First, let's create a proper map to show the flight connections, which you can do very easily in Python. How? First of all, you go to the Athens International Airport webpage, and they have all the connections, all the flights there, all the direct flights. So we just scrape them using beautiful soup and requests in Python. We download everything, and then we use base map again in Python, and we draw this. And so here you can see everything. These are the actual flights that connect Athens to every other place on the world. And actually, the geometry is also correct. Okay, so problem solved in this case. And then the other thing was with the visas. Then again, for the visas, it turns out that if you go to the Ministry of Foreign Affairs in Greece, in the web page, they also have a table with all the countries where you don't need a visa to travel from these countries to Greece. So again, you write a small script, we take all the data, and then we use basemap. And this is actually the proper situation of visa-free travel to Greece. So this is what actually ended up in the bid, so we corrected other stuff as well. We also submitted this, and we won. Okay, so we got a conference, we're organizing in 2 years, so you are welcome to come there. So that was the first thing, something just simple visualization that helped us in everyday tasks. So all these things I showed, it's just like 5 or 10 lines of code, nothing more. Okay, so you could do that with 10 lines of code and create these nice graphics in Python, make your life more productive. Then moving to, let's say, more scientific stuff, lots of people use Python for things like statistics, for example, and data analytics. And Python has a very good library for that. For example, this is a library from an instance from a library called SAS Models, where you can use a correlation plot. What we have here is you have a series of medical conditions, and you want to see which of the two are correlated to each other, right? So there's one command, you run it, and you get this, which for every pair that you have here, it will show you which ones are correlated or not, corresponding to some color code. The problem is that this is difficult to interpret. Okay? I mean, probably you don't understand what this map shows. So the good thing with Python is that it's easy to do it yourself. So once we had the CMAT, then I said, okay, let's create something that's more user-friendly. And again, with something like 20 lines of code, you can do something like this, with the same thing as before, but it actually plots a very small image of a correlation between each pair of variables. So you can actually see exactly how they are correlated. And you know, if you remember from basic statistics, when two variables are correlated, they are flatter. Okay, they look like a line. Otherwise, they balloon. This is what you see. You also see that you can have positive correlations and negative correlations, because you can also plot the slope in this way. And it's difficult to see here because of the analysis of the screen. One thing that is important when you do statistics is the statistical significance. So you may have a correlation, but it may not be significant after all. And you can see that because you see a dotted line or a solid line. So these are the values that you can actually take seriously or not. And again, right, this is just something you can do with 20 lines of Python code. Now, talking about statistics, there was a famous guy, perhaps some of you know him, Hans Rosling. He was a Swedish guy who ran a foundation called Gapminder. He died 2 years ago. The foundation was called Gapminder because what he wanted to do was to mind the gap, our conceptual gap between the things that we believe we know about the world and the things that happen in the world. So he created a very nice website with fantastic visual displays about world poverty, life expectancy, movements of population. And you can, if you have not seen him, you can also check out, as I said, he died, but you can check out, he has some amazing talks. He was very popular at TED, so you can check him out. And for example, this is one of the graphics from his websites, where you have life expectancy on one axis, and income per head on the other one. And here are all the countries in the world, and you can actually see the relationship between income and life expectancy. Now, these are, if you go to the gapminder.org website, it's fantastic, it's awesome. You can create also your own graphics. The visual engine behind all this is JavaScript using Node.js, so it's quite some effort to create the infrastructure for creating this kind of graphics. So then the challenge is, can I create a graphic like that using Python, again, with a few lines of code, right? So we start, and we use a tool called matplotlib. We download the data is available from the World Bank, and the way we work, we do these things in iterations. So at first, we download all the data for all the countries, We have income per head, and we have life expectancy, and we make a plot. This is a couple of lines. So our first effort looks like that, which is nothing like what we would like. Then we can start improving. So what we can do is, let's make each country as big as the population. So now you get a better image, all right, because some countries are definitely bigger than others. So the life expectancy there is more important in some aspect than others. So this is the second effort, which we just added another little detail, which is just the size proportion of the population. Now this plot is a bit misleading because if you see the scale of the vertical axis, it grows just a bit. I mean, nobody lives for 1,000 years yet, right? But the income changes a lot because there are very poor countries and very rich countries. So when you have this kind of problem, then you have to change the axis and to convert it to logarithms, which is what we do, and then it appears like that. And now here, you start seeing a pattern that there is a correlation, like linear, between the income in a country and the life expectancy. So richer countries have people who tend to live longer. But then something that we may wonder is that, right, we have the countries here, and we also have the size of the population, but is there any difference in terms of geographical regions? For example, sub-Saharan Africa is poorer. Do also people there live shorter lives as well? So with one minor tweak again in the plot, we can color code the geographical regions. So for example, you see, yes, sub-Saharan Africa, for example, is this group of countries. So they are poorer, and they live shorter lives. And this part here is basically Europe, United States, and Southeast Asia. Okay, you see how privileged we are. But our real target was to create something that is actually interactive, like the one that Hans Rolling did. So you can, if you want to have interactivity, you cannot do it with Python right now, because with Python you create only static images. But there are libraries in Python where you can output JavaScript images, which is what we did here, which is what I did here with a library called Bokeh. So here are all the countries again, but there is some interactive. For example, if you hover over any country, you will see which country it is, and the population, and the name of the country. You can also try to see where is Greece. So Greece is, let's see, this is Greece. So despite the financial crisis and all that, we are near the top of the table. Okay? And the other thing you can do here is that actually this is interactive, so you can see the history. So you move back in time, because I have taken the data from the beginning of the 19th century to today, so you can see how everything changed along the years. So for example, if we go back, right, you see in the beginning of the 19th century, life was nasty, brutish, and short for everybody. Like you see, there was no difference really between Europe, United States, and the rest of the world. And then as we go on, see the situation remains the same until the second industrial revolution starts happening. And then you see some countries flying up. This is Europe and the United States. And you see they go up and go, and they still get better and better. And then something happens after the Second World War, which is that the rest of the countries start catching up. So, and you see the plot is flattening, right? So you see how it is from something that is very unequal to something that's more equal. So despite all our complaints about the present state of the world, it seems that for the last 50 years, we are doing something right. Like, although not everybody has got richer, at least they live longer. Now this again, okay, just a few more lines of Python. Okay. And the interesting thing is that as I was doing this, and I was playing with this back and forth when I first created the plot, and then if you notice the two blobs, the green ones, this is China and India. So if you see what's going on here, you see China is above India, and then somehow it goes down. You see, it dives. It's like they dance, around each other. So when I see that, I said, okay, fine, I made a bug. Okay, because countries are not supposed to go up and down like this in terms of their life expectancy. So I started checking my code to see what could explain this sudden movement. And the code was right. It's history that explains what happened. If you see the timeline, it's the cultural evolution in China, in the 50s and the 60s. So if you really want to see the effects of the cultural evolution in China, this is what happens. They lost about 20 years of life expectancy. Okay? And then they caught up. So this is also a good lesson in social policies and whatever. And I found out by mistake. I had read about the cultural evolution, but it was the first time that I really saw what it meant to the population over there. Okay, so this is another thing that you can do just with playing with Python. And since we're talking about life expectancy, we can also analyze a bit how long people live in an individual country over the last 200 years. So we can try to, we can emulate some plots created by sociologists at Duke University. We take the data from something called the Human Mortality Database, which for different countries, they have data like this. So they have year, for which they have data, the age, and the percentage of the people who died when they were that years old. So at age 0, you see 20% of the population died. And then it gets better and so on. So we can take this, and we can manipulate it a bit with a library called pandas. So we take the data, and we create a pivot, and we group a bit, and then we can create a heat map. So we can create a plot like this one, which shows the situation for France for the 1816 to today. And what this map shows is, for every year, the proportion of people born, so there were 0, 1, 2, 10, 20, 30, 40, 50, 60 years old that died at that year. So what you see basically is that life is just a short window between 0 and nothing. So most people make it until to the 50s or 60s, and then people start dying out. Right. Now this image is okay, but again, I am a perfectionist, so there was a problem. You see that it has some kind of patches, okay, discrete patches. This is because I just plotted the image using the defaults by a visualization library called Seaborn in Python, but you can actually do something better if you use matplotlib. So this is the same image as before, but it's not, it doesn't have these fine patches. And again, it shows the same information. So you see, as we grow old, we die. This is a sorry state of affairs. What also you find out here, though, is how much infant mortality reduced. So if you were born at the beginning of the 19th century, right, not many people made it after, 5 years old. So you see how many people, the probability of dying in the first years of life was really, really high. And the situation only improved and infant mortality disappeared after we had modern antibiotics. So after the Second World War. So that's another important lesson. The other thing you find here is that you have this plot, and then you have this here, this blot of black, and this. And these are the 2 world wars. So this is, you see how many people between 18 and 40 years old, they were dying in France at that point. So here you see what happened in the war in France, the First World War. And here's the second, which is a bit surprising, because in the Second World War, actually France didn't fight, right? I mean, okay, there was, but it was very brief. So, but you see is how many people died. So this is the situation for the male population, and this is for the female, where again you see something surprising. You see that although women also usually don't fight in the war, they suffer the consequences. So again, here you see this and this dark line, people dying, right? And once we have this for France, right, I picked France because they have good statistics, so we have data for many years going back. You can also do it for United States. Unfortunately for the United States, the data goes back only to the 1930-something, so there's not much to see. You see, although they fought in the Second World War, it didn't affect their population a lot, okay, because they were never occupied. And also, you don't see anything, although the Vietnam War was very important, it didn't affect in any way the general population pattern. We can also do this thing for Greece. Greece has very lousy statistics. Only 20 years, sorry, nothing to see there. And then you can also do it for the Netherlands, since we're talking about Python, and it was born there. And the Netherlands were also, you know, they did well. They had the casualties in the two world wars. And you see here these bright spots. These were a bit strange when I saw them. It means that if you get up to 100, then the probability of dying is 0. So, you know, so yeah, it's... So I checked. The code didn't have any bugs. The data is buggy, right, again. So it's a usual story, garbage in, garbage out. So the Dutch have fantastic statistics, but they have a problem with the centenarians in the 150 years ago. So anyway, but I let it like that to show you what happens when you have bad data. Now, I am a software engineer, so we're going to use the same kind of visualization, the same kind of analysis to analyze the state of code. And what we did, and this is something that has been accepted for application in a conference in 2 months, is the state of JavaScript code in the wild. Okay, so can we find any patterns to explain what is happening with JavaScript code in websites that are outside in the world? So what we did is that we selected the top 10,000 Alexa sites. So these are the most popular websites in the world for 6 months. And we're downloading for 6 months every day all the JavaScript files that were found on these websites. So there were like 50,000 inline external scripts per day and about 140,000 inline scripts. That meant that we ended up collecting 2 terabytes of data, and we added them up after some manipulations in a 65 gigabit repo to be able to analyze them. So how did we analyze the data? We took all the scripts, and we wanted to see how JavaScript changes and patterns of change. Now, when you want to see how a program changes, it's tricky because like you may have a difference in white space somewhere. Okay, this is not a real change. Or you may see an identifier changing name. This is probably minor change. It's also very difficult to spot it's also very common in JavaScript because a lot of code in JavaScript is automatically generated, not by programmers. So they have these artificial identifiers. So to get around this problem, we used a program called Acorn. So we got abstract syntax trees out of the code, which we then anonymized it. So we took out the identifying names and the names of the functions and all that, and we just kept the structure. And we used hashes of that to see how the things evolve. And what we found first is that websites change very, very often. Right? Almost every few days, you have a new version of the website, not in terms of the content, right? In terms of the code. So it means that people are pushing new JavaScript code into production on average every few days, as you see here. And then once we have that, then we say, OK, now let's check the popularity of JavaScript libraries over time. So over this 6-month period, which are the most popular JavaScript libraries that were used over these 10,000 sites? And you see, this is the graph that we got. jQuery is by far the most popular one. Okay, and then you got some other ones that have to do with user interfaces, plus the third most popular one is ads by Google. So obviously, a lot of people use Google Ads. Again then, once we had the libraries, the next thing we could do is to see how many of them were vulnerable, which means that the websites themselves were vulnerable. And to do that, we used a tool called Redirect.js, which identifies real vulnerabilities that have been reported, and it's based on hashes, and it also has a sandbox environment. So we used Redirect.js, and we found that there were tens of thousands of libraries, JavaScript libraries out there in the wild that had problems, right? And not all of them were fixed in time. So you see, it took a lot of time to fix them. It means that you had websites having vulnerable libraries for tens of days or even hundreds of days. Okay? People did not care to fix them, it seems. And which were there? Again, we turn to visualization. Now, when we first plotted this, we had a problem because The most popular vulnerable library again was jQuery, which was much more popular than anything else. So when we plotted it, we had this line, and everything else collapsed. So you have to create this funny plot where you split the axis. So you have one axis with 1,000 and one with hundreds and one with tens to see exactly what is going on. So you see the most vulnerable libraries over time. And then the question is, if a website had a vulnerability, did they fix it? And then we had these other kinds of plots. So here is where we plot all the sites, okay, that started out with 0 vulnerabilities and what happened to them during the study period. And you see, most of the sites actually do a good job. We had 5,000 sites with 0 vulnerabilities, and most of them just moved between 0 and 1, 0 and 1. So you see, you have this thing. They had a vulnerability, they fixed it immediately. They had a vulnerability, they fixed it immediately. So they're doing a good job. Then when we move to a website that already had one vulnerability, you see again what's happening. It increases, but mostly decreases. So again, we have like 4,000 sites, so there's a lot of information in this graph, and you see mostly going downwards. So people are doing a nice job. And the same thing for 2 vulnerabilities, 3, etc. So we're seeing that at least the web developers are patching up the websites, mostly. So, as I don't have much time. And then, apart from vulnerabilities, we have something related to that. My time is running up, so I'm finishing. Which is something related to what we heard before about PyLexer. It's issues in code that are not vulnerable. We're not talking about vulnerable code, we're talking about code smells or quality issues. In JavaScript, you don't have PyLexer, you have something called JSHint, which we used Python to call JSHint on all the scripts of all the first 1,000 websites. We found some of the very well-known websites have a very lousy record in terms of quality issues. For example, Facebook had about 100 quality problems per day. Twitter, 106, and the CNN, 204. Okay, we're talking about bad style, bad practices, potential bugs. So these are per day, the number of issues they had per day. If we plot everything, so here we plot all of them, you see every line corresponds to the history of vulnerability of code issues per site for every day. So if there's something to make out here, is that you see they cluster in horizontal bands. That means that the situation remains the same. That is to say, if a website has, let's say, 100 potential issues, it tends to stay stuck at that number. It doesn't get better. Okay? So if you do not pay a lot of attention for quality, it seems that you go on like that from the beginning to the end. Okay? So it's like it's your modus operandi or something. Then we wanted to find out which sites were the ones that were trying to address the quality issues. So the first attempt was to create a histogram where you see that you have some sites with a great number of issues. For example, Facebook, I said, had 100. There are others that had 300, and some that had very few. But this doesn't show you any kind of fine, detailed information of which sites were there. So as I was toying with this visualization, I said, right, let's change the axis and just put the sites in alphabetical order. And then we got this. So here you see all the sites, 1,000, and the number of issues they had per day. And what do you see? You see G has 0 issues. You know what this? Google did a wonderful job. Google was the one host that didn't have any issues throughout the study period. Okay, so well done, Google. Okay, and this is something that we found out just by playing with the data. Right? It would not be obvious from a histogram. It just happened when I had the idea, let's change the axis and take everything alphabetical order. And then you see, pop, this thing. My first thought again was probably this is a bug. It's a fluke. It cannot be. What's going on with G? It's a G spot. What is this G spot? And then, and then I said that G spot is Google. So now I'm really drawing to an end. We are going back to fun. Okay, and this is the last thing in the conference, we'll try to answer this important question, which is what to watch on the TV. So, so people say that we are going through a golden era in TV because you have HBO, you have Netflix, you have so many companies that produce excellent shows. I think Game of Thrones arrives next month or something. So the question is, which are the good shows? Okay, and in fact, you can find out, or this is what I thought. I borrowed an idea from an economist visualization they had in the Economist newspaper. So I downloaded all the ratings from IMDb. You can do that. So if you go to IMDb website, you can download everything. So you can download the ratings for about 5 million titles. These are all the movies and all the episodes from the beginning of the cinema to date. So I downloaded all of them. That means that you have about 2 million movies and 3 million, almost 4 million episodes. This is what I'm interested in because we're talking about TV series. And you have about almost 1 million ratings. And episodes are individual things, but you have to group them in seasons because you are interested in watching seasons of shows, not just one episode. So when you do some grouping, again, you use pandas, okay, so you do grouping and some fancy manipulation, you find that you have some tens of thousands of seasons, and since I am interested in watching something that is at least acceptable, I reduce the data set to only those seasons that have a rating of 5 out of 10, because the rest is completely rubbish. Right. So we ended up with 16,000 seasons. And when you plot that, so the information, as I said, a small aside, the information is in terms of CSV, comma-separated values files. So for example, this is the information that you have for the titles. So you have the title of the film or the series, the original title if it was not in English, some indication. So this is the kind of information I had. You remember, this was like 5 million, more than 5 million lines of information. Then when I started manipulating information, after a while, I realized I was getting nonsense. And I wondered why. And I found that there was a problem somewhere with the data. One of these 5.5 million lines had a problem. And I found out, in fact, it was line number this. Okay, so the problem is that the title had the starting quote and not an ending quote. And how do you find this? Again, thanks Python. Okay, I mean, you can never find this on an Excel table. Basically, you do binary search. So you start reading everything, and when you see that you get rubbish results, you split and you split and you split. So I just wrapped the reading process in a small binary search, and I was able to find it immediately. Otherwise, it would be impossible. So, by the way, MDB, I think now it belongs to Microsoft, so even they have crap data. So you see, they have to fix that. Anyway, in the end then, what you get is that you get a plot like this. Now, this is the whole history of television from the 50s when we had public television available for everybody to today, and every plot is a season. So you remember we have 16,000 seasons, right? With a rating of 5 and above. So you have the year and the rating of each season, and then you also have a color. The color is the logarithm of the number of people who actually rated this season. Because it's important to know, because you may have a season that got a 10 out of 10 by a single person, or you may have a season that has like 9 out of 10 voted by, I don't know, 10,000. So you should know that. So the color code is important. The darker, it means more people watch that. So then you can go over here, and you can actually see for every single season, okay, what was the rating and what was the season. So you can pick everything and see, and this can help you, right, decide what to watch if you haven't watched it. So you can do that for everything, right, for every season. And then the question is, which one do you think, some of you probably know because I have shown this slide to some of you before, so those of you stay quiet. Which one was the best season ever? Anybody? Guesses? So that means which one had the best rating and the biggest number of reviewers? Game of Thrones, right. Another one? Right. So Game of Thrones, Friends, another Seinfeld, right? Seinfeld. Anything else? Which one? I don't know that, but I'm sure it's fine. Yeah. Any other? Yeah, lost. So what? Okay. So what we can do is that we go, and if you hover, you see that this is here. It's the darker and most popular one. And yes, it's Breaking Bad season 5. So this is what. So now you know what to do tonight, right? Thank you. That was a wonderful conference. That was all from me.
Thank you. That was a fantastic talk. Thank you very much. Visualization is so super important. I noticed you you spoke about the death rates during the Second World War and all that. That was really good the way that was presented. There's something quite interesting that you might want to look at, and perhaps our crowd might want to look at. There was a very, very cool project done by a Greek architect in the late 60s or early 60s that is currently on display in the Smithsonian. The architect's name was Konstantinos Doxiadis, and there is a great kind of hand-drawn visualization of all of the losses to Greece during the Second World War and the occupation, etc., etc. So that's a really interesting thing, because that statistics, of course, is very difficult in our country, and but there's a really good visualization, at least. But thank you very much. We now know what to watch the rest of this weekend. Let's go for some questions. Where can we find the visualization script sample or actuals?
Well, is there? I don't know. Do you have a conference website? Can I put them somewhere? Links in the conference website?
We do.
All of them are my own scripts, so yeah, it's just Python, and basically most of them Python notebooks. So yeah, no problem sending them.
I think the organizers can probably put together some sort of repository or something that our speakers could throw in some code if you guys want anything. Okay. Which web scraper are you using?
Yeah, nothing fancy requests.
Okay.
Nothing fancy.
Nothing fancy.
Yeah.
And your favorite?
Sorry. Requests for the request for the original stuff where I scraped the airport and the ministry. For the JavaScript thing, we built a special Python tool which we call Night Crawler, because it was crawling throughout the night for every day for this half year. This is also open source. I can also give you a link. It's called Night Crawler. It visits website and downloads the JavaScript scripts of the website.
Okay. And favorite plotting library?
But I don't know. Matplotlib is you can do fantastic things with it, but it's awful in terms that you have to spend so much time learning it. Seaborn is fantastic because it gives you ready-made visualizations that look nice, but if you want to customize it, they can be tricky. Not a single one. Yeah, JavaScript, D3.js is fantastic if you want to spend a week on a single drawing, right? Because it's so difficult to do it right. Well, so it depends. Yeah.
Any final questions? Well, thank you very much.
Okay.
Thank you. Great final talk.